In this video, we're going to go through the process of a chi-square independence test in Excel, so you can get a hands-on example of how to work with this. So here we're looking at the relationship between two categorical variables. First, we have the four levels of job satisfaction. They range from dissatisfied to satisfied. Now, looking at this should be setting off alarm bells for you if you remember the Likert scale assignment. Now, this is a poor example of a survey question because there are only four responses. It doesn't include the perfectly neutral. But despite that issue with the survey that they use to create this data, we'll go forward with this example because it's from the textbook resources. And for the second category, we have the type of pay the workers receive. So either performance pay or seniority pay. Now, if we look at the data, there are 29 individuals in the sample that are paid on performance and that are satisfied with their job. There are 17 that are paid based on seniority that are satisfied with their job, 38 that are paid on performance that are somewhat satisfied, so on and so forth. So our question here is there a relationship between satisfaction and the type of payment that workers receive? Or alternatively, we can phrase it as the question, does satisfaction vary with the type of payment plan? So this is the type of question that chi-square tests are made to answer. The null hypothesis in this case would be that there is no relationship between the two categorical variables, that they're completely independent of each other. The alternative hypothesis would be that there is a relationship. So let's look and see how we do this in Excel. We'll work through the math so that you can see how it works. Then I'll introduce you to a macro that makes doing a chi-square test analysis in Excel very simple. It saves you doing some of the math, but it's important to first look under the hood. So let's look at our problem again. We want to know, is there a relationship between the two payment types and job satisfaction? First thing we need to do is calculate the row totals and the column totals. I've done that here already, but I'll show you the formula. Basically just a column total. The first one right there, just that column. The second one here, based on seniority, that column. I also do the rows here of just those two columns across. I took the sum of those, the row totals and the column totals should be the same. If it's not, then the math is wrong somewhere, or I guess it's a poor example. But we have 212 total observations in here. Now, the next step is to use the row and the column totals to calculate the expected frequencies if all the categories were independent. So I've done that here. It's a decent amount of typing, so rather than sit here in awkward silence, I've done this ahead of time. So for performance here, we have performance and satisfied. We have the row total, 46, times the column total divided by 212, the absolute total. And we have that for each of these categories. So for 38 here for satisfied and based on performance, we have the 71 total here instead of up here previously. So this is what it would be if if the type of payment plan and job satisfaction were totally independent. Now that we have that, we can go down here and fill out these columns to make the chi-square test easy. So for the rows, we have four rows. No, I'm sorry, we have two rows, and then we have four rows, that was right, and then two columns. So degrees of freedom are the rows minus one times the columns minus one. So 4 minus 1 is 3. 2 minus 1 is 1. So 3 times 1 is 3. And their alpha, we're going to select 0.05. That's the common one, the 95% confidence interval. So first thing Excel does is it calculates the p-value. So it does that first before you calculate the chi-square statistic. So it's the opposite of what we would do if we were doing the math totally by hand, but that's just now that's the way that Excel works. So we'll do the p-value. So we go to I have that in parentheses there. We go to function and choose the chi-square test. That's in one of my previously used ones. So now for it's going to ask for the actual range of data. So this is the actual data that we started with. So select that, and this is our actual data. We don't want to include the row totals, just the raw data itself. And then for the expected range, we go down here and include the expected data. And that gives us our p-value 0.00 0.18 or 0.002. So very small p-value. Next, to get the chi-squares, we use this chi-square inverse, so the chi-sq, so chi-square dot iv dot rt. We're going to use the chi-square function. So we'll highlight that spot, the chi-square function. Again, this was one of the previous ones that I used, but you can also go in here and type, and that'll bring up, I just did the start of the formula. You can bring up anything that has that keyword in it. So pull up the one that we want. So now our probability, that's us asking us for the p-value. So select your p-value there. And then the degrees of freedom. So go over here to degrees of freedom, select that. And then we are ready to go. And that spits out our chi-square statistic, which is 14.99, so basically 15. Then we look at the p-value. So the p-value in this case is 0.002. So since the p-value is less than the 0.05 that we set as our alpha, we conclude that the chi-square test is it's extremely unlikely that if there were no relationship that we would reject the null hypothesis. So now I'll show you how to do use a macro to do all this. So we're going to there's a file on the page in this module that has linked to this Excel. Yeah, so this come blank and we would fill these in ourselves. So select the number of rows. Again, we have 4 rows, we have 2 columns, and the alpha is 0.05. So we paste our data into here, the raw data that we had. And now just hit calculate. And that gives us all the information here. So we have the expected outcomes here that it calculates for us, which is really cool. Calculates the row and column totals, and you can see the total number of observations. And then it does the p-value for us, the degrees of freedom, the critical chi-square, the chi-square Excel function, and then it gives us the results. So we reject the null hypothesis because the p-value is less than the alpha value that we set. So we conclude that the alternative hypothesis must be true. So that's an example going through Excel to show you what we do with the if we want to do it by hand in Excel or if we want to use this this macro.